this video, I will show to you how to solve a problem from the Book of Mechanics of Material, 4th edition by Beer and Johnson. But before that, I will introduce myself. I'm Nino Romar Obalde from BSEE 2A. For this problem 7.102, a spherical pressure vessel has an outer diameter of 3 meters and a wall thickness of 12 millimeters. Knowing that for the steel used, allowable stress is 80 megapascal, the modulus of elasticity is 200 gigapascal, and the velocity is 0.29. Determine A. the allowable gauge pressure, and B. the corresponding increase in the diameter of the vessel. For that problem, these are the given. Diameter or D is equal to 3 meters, thickness or T is equal to 12 millimeters, which is equivalent to 12 times 10 to the power of negative 3 meters. Allowable stress is equal to 80 megapascals, which is equivalent to 80 times 10 to the power of 6 pascals. The modulus of elasticity is equal to 200 gigapascals, which is equivalent to 200 times 10 to the power of 9 pascals, and the velocity is equal to 0.29. First, we need to get the inner radius by using this formula. R is equal to D over 2 minus T, and we substitute all the given data. R is equals to 3 halves minus 12 times 10 to the power of negative 3, and the result is R or radius is equal to 1.488 meters. For allowable stress, hoop stress is equal to longitudinal stress is equal to allowable stress, which is 80 megapascals or 80 times 10 to the power of 6 pascals. For part A, in order to get the allowable pressure, we will use this hoop stress formula, which is sigma sub 1 equals to PR over 2T. And by using this formula, we can formulate another formula in order to get the allowable pressure, which is P equals 2T times sigma sub 1 over R. And we substitute all the given data, which is P equals 2 times 12 times 10 to the power of negative 3 times 80 times 10 to the power of 6 over 1.488. And the result is 1.290 times 10 to the power of 6 pascals or 1.290 megapascals. For part B, in order to get the increase in diameter, we will use this formula. Epsilon sub 1 equals 1 over E times sigma sub 1 minus V times sigma sub 2 and epsilon sub 1 equals 1 minus V over E times sigma sub 1. And we substitute all the given data. And sigma sub 1 equals 1 minus 0.29 over 200 times 10 to the power of 9 times 80 times 10 to the power of 6. And the result is 284 times 10 to the power of negative 6. And by getting that, we can solve the increase in diameter by using this formula. Delta D equals D sigma sub 1. And we substitute all the given data, which is delta D equals 3 times 284 times 10 to the power of negative 6. And the result is 852 times 10 to the power of negative 6 meters or 0.852 millimeters. For this problem 7.102, the results for A, the allowable pressure is 1.29 megapascals, and for B, the increase in the diameter is 0.852 millimeters. And that's all. I hope you understand my video tutorial, and thank you and God bless.